Vector algebra, exercise number 10.2. Question number 1. Calculate the magnitude of following vectors. We are given one vector I plus j plus k. Suppose vector A is given as AI plus bj plus ck. All will contain cap. So magnitude or modulus is given by sum of squares of coefficients a square plus b square plus c square. So here coefficients are 1, 1, 1. So suppose it is vector A modulus, then it will be equal to 1 square plus 1 square plus 1 square. 1 square, that is root 3. Similarly, in case of second, if we find modulus b, so it will be square root of 2 square plus minus 7 square means same as 7 square. Similarly, minus 3 square means 3 square. And then we can simplify. Vector c modulus will be 1 upon root 3 outside, then square root of 1 square plus 1 square plus minus 1 square, that is 1 square. So it will be root 3 upon root 3, which will give 1. Let's go to question number 2. Write two different vectors having same magnitude. Suppose we write vector A equal to I minus j, and we find its magnitude. So it will be 1 plus 1 means 1 square plus minus 1 square, that will give 1 plus 1 root 2. And suppose we write vector B as I plus j, and then all ijk will contain cap. So if I don't write, so sorry for that, but you have to write in exam. So it will be 1 plus 1, that is root 2. Write two different vectors having same direction. Same direction means unit vector should be same. So suppose we write vector A equal to, suppose I plus j plus k, then vector B will be a constant times vector A. That is, suppose we double it. So 2i plus 2j plus 2k. We can triple it, we can make it half, etc. Still, direction will remain same. Now, find the values of x and y so that vector 2i plus 3j, 2i plus 3j is equal to xi plus yj. So here, corresponding coefficients of I and j must be equal. So x will be equal to 2 and y must be equal to 3. Find the scalar and vector components of the vector with initial point 2, 1. So this is 2, 1. Suppose this point is A and this is B, which is minus 5, 7. So let's find out the vector. So vector AB. So to write vector AB, we first write the coordinate of B, then that of A. So here minus 5 reduced by 2 times I cap, and then 7 minus 1 j cap. So it will be minus 7 I cap plus 6 j cap. Here, this 7 I cap and 6 j cap are vector components, whereas minus 7 and 6 are scalar components. So we have to take sign minus 7 I cap plus here minus 7 I cap and 6 j cap are the vector components, and minus 7 and 6 are the scalar components. Let's go to question number 6. Find the sum of the vectors. Three vectors are there. So it is very simple. Suppose we write it as, say, vector D, assuming that these are ABC, A plus B plus C. So here I, 1i, this is 2i, 3i plus I, that is 4i. Then minus 2j plus 4j will become 2j, 2j and minus 6j will become minus 4j. And then k, 1k here, 5k, 6k, 6k minus 7k will give minus k. Now find the unit vector in the direction of vector A. The rule says that unit vector in the direction of vector A will be given by vector A divided by its modulus. So this would be denoted as A cap. So here A cap will be Vector A means same vector I plus j plus 2k divided by square root of modulus. Modulus means coefficients are squared and summed up. So 1 square plus 1 square plus 2 square. So that is I plus j plus 2k divided by this will become 4 root 6. Let's go to next question. Find the unit vector in the direction of vector PQ, where P and Q are these points. So first of all, we have to find out a vector PQ. So PQ means difference of the two, that is 4 minus 1 I cap plus 5 minus 2 j cap plus 6 minus 3 k cap, which will become 3 I cap plus 3 j cap plus 3 k cap. Now we need a unit vector. It means suppose we denote it as vector A, then we need vector A cap, that is vector A divided by modulus of vector A. So vector A is 3 times I cap plus j cap plus k cap divided by modulus of this. So either we take common like this and then we take modulus, or we can put these values together. So two ways are there. So let's write 3 square plus 3 square plus 3 square. So it will become 3 times I plus j plus k divided by this will become 9 plus 9 plus 9 root 27. So we can write this 27 as 3 root 3, and then 3 will cancel out, and then we will be left with I plus j plus k divided by root 3. Another method is also there. Here directly we can find, like suppose we take this vector A equal to 3 times I cap plus j cap plus k cap, and to find its modulus we keep 3 outside and then we write a square root, that coefficient 1 plus 1 plus 1, so that will be 3 root 3, and then A cap will be vector A divided by modulus A. So this will be equal to 3 times I plus j plus k divided by root 3. So times 3. So again it will give same thing, I plus j plus k divided by root 3. Now let's go to next question. Are given vectors A equals 2I minus j plus 2k, and vector B is given as minus I plus j minus k. Find the unit vector in the direction of A plus B. First of all, we have to find out A plus B. Suppose A plus B is a vector C. So we find a sum. So this is 2I, this is minus I, which will give I. This is minus j, this plus j. So it will become 0j. And this is 2k, this is minus k, this will give k. Now, so we have got vector C as I plus k, and we need a unit vector. So unit vector is C cap, which will be vector C divided by modulus of vector C. So that is I plus k divided by modulus will give root. Now, let's go to question number 10. Find a vector in the direction of vector 5I minus j plus 2k, which has magnitude. Suppose this is vector A. So 5I minus j plus 2k. We find its magnitude. So it will be a root of 25 plus 1 plus 4. So root 30. Now we find A cap, which will be equal to vector A divided by modulus A. That will be 5I minus j plus 2k divided by its modulus, that is root 30. Now required vector is equal, suppose it is vector B. So that is 8 times 8 times a cap. So it will become 8 by root 30 times 5I minus j plus 2k. Now, question 11, show that the vectors are collinear. So, vector A equal to 2I minus 3j plus 4k and vector B equal to minus 4I plus 6j minus 8k. If two vectors are collinear, then suppose A must be equal to lambda B, where lambda is a non-zero a real number. So let's see whether we are getting some value of lambda or not. So if we write 2I minus 3j plus 4k equals minus 4I plus 6j minus 8k. Here we can take common minus 2. We will get 2I minus 3j minus 4k. So your minus sign is taken common, so it will become plus 4k. So this is vector B. So this is vector A. Clearly, vector B equal to minus 2 times. Vector B is minus 2 times vector A. So lambda is minus 2. Hence, we can say that these two vectors are collinear. Find the direction cosine of vectors this. Suppose we are given a vector A equal to I plus 2j plus 3k, then direction ratios are coefficients of ijk. So 1, 2, and 3. Now, direction cosines can be found by, suppose this is A, this is B, this is C. So direction cosines are L or cos alpha. That is A upon root of A square plus B square plus C square. So A is first value. This can be written as plus minus also. So I'm taking positive only. So 1 and then square, sum of squares of these. 1 square plus 2 square plus 3 square. So it will become 1 upon root of 9, 430, root 14. Similarly, M is cos beta, which is second value, B upon root of A square plus B square plus C square. Then it will be 2 divided by root 14. Similarly, N is cos gamma, which is equal to C upon root of A square plus B square plus C square. So that will be 3 upon root 14. So this is our answer. Thank you for watching.